In this video, I will highlight some things that you can do to take this assignment, assignment 11, the full section assembly, and convert it into blocks and make it a little easier to work with. Some blocks that you can take advantage of in the AutoCAD Design Center, and some things to do with your hatches to distinguish one part from another. So here is the assignment. We've got different parts that we're going to all fit together in one assembly, and then we're going to make a full section out of several of these parts. Now, some parts that you don't show in section: axles and fasteners. When we talk about fasteners, we're talking about this note right here. We have a bolt and nut and a washer that all become part of a fastener assembly. If you can imagine, those parts wouldn't be part of this drawing in terms of what this drawing is used to actually manufacture, things like the axle supports and the top plate and the wheel. And the bushings would all be manufactured parts for this assembly drawing. The fasteners would not be, they would be purchased from someplace else. So we're going to take advantage of the AutoCAD Design Center to have those ready drawn. They just need to be adjusted a little bit. So we'll do that in the block editor. So from the dimensions that you have on this handout, you're going to combine all those pieces, and your end result drawing should look something like this. In my drawing, I have some overall dimensions, which are common to a full section assembly drawing. I have in my front view is shown in full section, and then I also have a right side view to see what this set of objects would look like from the right hand side. I have also gone ahead and added some cutting plane arrows to indicate where this is shown in section, and also to indicate that it is indeed a full section. So in creating the geometry for these individual pieces, I've taken a look at each piece in turn, and I've created the geometry. Here's my axle, here's my top plate, here's the bottom part of my wheel. What I was looking for in the handout were common patterns. So you can see this is the area of the wheel that I drew, which will mirror the top half. That's why in my drawing I've only got this portion of it. When I created that geometry, I also turned it into a block with the block command. I did the same thing for the axle. Notice the axle and the top plate, I've already taken out the holes for where pieces will be assembled together with that bolt nut assembly before I made those into blocks. The bushing, I only needed this one area here. This will be part of the pattern that I'll repeat on the other side. The main reason for turning these items into blocks is to keep them easier to work with. You'll also notice, if you take a look at the handout, that we have pairs of a lot of these objects. We have 2 axle supports, we have 2 bushings, we have 2 sides of the wheel shown in section. And once I make these into blocks, they're easier to manipulate and fit together. They'll also be easier to mirror to the other side. Some additional things that are part of this drawing: the 2 lines on the top are shown in a phantom line type. That information comes from the steel plate note here. Show the steel plate in phantom lines. This entire assembly is bolted to that steel plate, and there's a note that will tell you in the drawing how far apart those should be in millimeters. So when I place these pieces together, they'll go underneath the steel plate, and then I'll fit the fastener assembly to that. I've also created an area here to help me redefine the block that I'm going to use for the bolt and also for the nut that's part of the fastener assembly. If I take a look at the handout again, you'll see the note here: fasten assembly to the steel plate by 4, 1, 2, 3, 4, M10 by a length of 40 millimeters, hex head, hexagonal head, bolts, nuts, and lock washers. There are a set of PDFs in the R drive for each of these different items. There's one for bolts, there's one for nuts, there's one for lock washers. If I open up my R drive, let me show you where to find those. R class 105, the lesson notes, and then the lesson notes for the full assembly drawing. Here are the PDFs. There's one for bolts, one for nuts, one for washers. Excuse me. If we take a look again at the size and how it's labeled, the name for the bolt and the nut, M10, is what we'll look for in the table, and then we'll add to the length of that. So, an M10 bolt. If I open up the bolt PDF, this is what that looks like. I get a diagram on the top, both in a top view and in a length view, that gives me, according to the table, what these dimensions relate to. So my M10 bolt is this size right here. For an M10, that tells me that the distance or the width across the flat edge to flat edge is this distance right here. And for metric, which is what we have, it's 15 millimeters. That's why in my drawing you see that I've drawn a hexagon with the polygon command, and I've made sure that from flat edge to flat edge I meet that dimension. I'll also be able to change the length of the bolt. The length here will be the 40 millimeters as identified on the handout. And then the thickness here, if I go back to that M10, the thickness should be 6.8 millimeters. So we'll have some adjusting to do there as well. Let me show you in AutoCAD where to find a ready-made fastener as far as being already a block, and then we'll go into the block editor and we'll adapt that block to be the right size for our drawing. AutoCAD Design Center ADC. I need to find the blocks that are ready-made in AutoCAD. So if I go to the C drive and then Program Files, Autodesk, AutoCAD 2016. In that list there's a folder called Sample, ENUS, and then I have choices, Design Center, Dynamic Blocks. We want the Design Center blocks. And we're looking for a drawing called Fasteners Metric. These will suit our drawings. If I open up the blocks category, you'll see that I have a hexagonal head screw, 10 times 20 millimeters in length. If I drag that off into my drawing, and then close the Design Center, we'll come back and get the nut in just a moment. I'm going to rotate that into position, and I'm going to align it underneath my hex head and place it on the object layer. If I track lines down from the points, you'll see that I have a little bit of editing to do to make this block the size that we need it. The circle here is also the diameter of the bolt shaft, which is 10 millimeters. Let's check to see that that's correct. It looks to be good. So the width of the shaft is correct. It's the other things that we'll do some slight adjusting to. We also know that the shaft itself needs to be 40 millimeters, so we'll make that change also in the block editor. I'm going to select that block and open up the block editor, BE. I'm going to redraw that hexagon so I have the right size to work with. 6 sides. I'm going to align the center of that shape with the center of my bolt. It's circumscribed because it's defined from flat edge to flat edge. And the radius of that, if it were 15 in diameter, it would be 7.5 radius. I'm going to rotate that so it's aligned with my block. Change my tracking to an angle that will work, 30 degrees. There. Now I have the points aligned with the outer edge and the two lines right here. Pretty minor changes, but this will work just fine. I'm going to use the stretch command and adjust those positions. And that's all set. I also need to stretch this out so it's 40 millimeters. Let's check first to see what the length of the shaft is. 20.3. I'm going to stretch that out. 19.7. And I have the length of the shaft that I need. Close and save. And now the bolt and shaft is the correct size. Use the design center one more time, and this time I'm going to bring in a hex nut, 10 millimeter. Side should be fine. Close my design center, rotate that into place, put it on the object layer, and I have those two pieces ready to use. Now the last thing that we need to create, and it will be just a basic rectangle with a line through it, is this lock washer that sits between the nut and the edge of the axle support. So I've checked my bolts, we've used that information. The nuts, you can also make changes to it. The format is the same. Look for the M10 and then use this information. So the nut should be in thickness, the H value, 9 millimeters thick. And the width across the flats will match the bolt. The other PDF that's useful is the washers, and we're looking really for the outside diameter, OD. Bolt size, we have a bolt size 10. We're looking for a lock washer. The outside diameter should be 10.2 and the thickness 2.2, these again in millimeters. So to create that, I'm going to draw a rectangle. I'm going to make it 20.2 by 2.2. Let's just double check and make sure I had that at the right size. 10.2. I made that 10 millimeters too long. 17.2, I'm sorry. 3 millimeters too long. No problem. I'm going to stretch that, make that 3 millimeters shorter. Then with the line command, I'm just going to draw a diagonal line. This is the symbol, rather, for a lock washer. Okay, I've jumped ahead a little bit and fit these blocks together in the way that they're shown in assembly. And now that I have these pieces fit together, I can mirror them to the other side. You'll see I've already done that with the block I made that represents the wheel in section. Okay. With those in place, the last thing I need to do as far as the drawing here in model space is to place some hatch patterns. Hatch patterns, if you remember, are specific to material. I've got several pieces made out of iron. We take a look at the handout. The axle support is made out of malleable iron, as is the top plate. The axle is made out of steel. Won't really matter to us as far as hatch patterns go because, as I mentioned at the beginning of the video, the axle won't be shown in section, but the top plate, the axle supports, the bushings, and the wheel will all be shown in section. So we've got some made out of iron, we've got some, the bushings, made out of bronze. We'll be using two different hatch patterns. It's also very important to show the patterns in such a way that they are clearly understood. If you see the same pattern all in one area, that indicates that this is one part. But as you know, we have two axle supports. So although I'm using the same pattern with the same scale, the hatch pattern for this axle support, I've reversed the angle to make them look like they're mirror copies of each other. So let's place some hatch patterns. Choose my hatch layer, H for hatch. ANSI 31 is the general pattern. It also represents iron. I have options for scaling and angles that we'll be experimenting with, but for now I'm going to place the pattern for the plate. I've got 3 areas where that plate appears in section, and I'm going to choose all of those areas by clicking inside and pressing enter. Double checking to make sure that none of the lines of the hatch pattern are parallel with any of the object edges. It's another way to distinguish the pattern. I'm going to use the same pattern for the axle support. I'm going to change the scale slightly so it looks a little bit different from the top plate. I'm going to make that a 0.8 scale. I'm going to change the scale of the angle as well, 15 degrees. Choosing all 3 places for that pattern. I need to place the same pattern here, although I need to edit the scale a little bit. The angle of these lines, originally 45 degrees plus another 15, meant that these are 60. I need to find the angle to mirror that on the other side. So same pattern, same scale, but the angle I'm going to add, I'm going to change that to an angle of 60 degrees, and that should give me a mirrored effect for the hatch pattern on the other side. I'm going to change patterns now for the bushing. H for hatch. ANSI 33 is the pattern that represents copper-based metals. This will work for bronze. I'm going to switch the angle back to 0 here and back to a scale of 1. That's a little too small. Change the scale. There, now I can see the pattern clearly. I'm going to press enter. So again, like the ANSI 31, it's already at a 45 degrees, so I'm going to reverse that on the other side by making the new angle an angle of 90 degrees, 45 plus 45. And I have my patterns. One more pattern to add for the wheel. This would be the same pattern, it's one object. Back to ANSI 31. Change that to 0 for angle. I'm going to increase the scale a little bit for my wheel to differentiate it from the plate. And there's my assembly.